All right, beautiful. So let's go ahead and work out some of these problems on 2.4. 2.4. So we're going to combine like terms. We're going to combine the like terms. The like terms. All right. So when we look at 3x plus 5 minus 10x, when we look at the like terms, which ones are the like terms? Well, the positive 3x and the negative 10x are the like terms. They're both in the X family. You know, we have the X family and we have the number family. Or said in a more professional manner, we have the variable family and we have the variable family would be the version with the letters. In this case, it's X. And we have the number family or the constant family. So the numbers are called the constants, the X's, the letters are called the variables. So two families, the variable family and the constant family, okay? So since these two are in the same family, we can add those two together. And since this one, the positive 5, is in a different family, we're going to have to add that to a different family. So that goes here, and that's a positive 5. All right. We have to add the positive 5 into a different family because it's not part of the variable family. So now we can combine our like terms with the variable family, the 3x and the negative 10x. So if you take out your handy dandy calculator and you have 3x minus 10x, it's really just like 3 minus 10. So if you had a number line and you went from 3 to negative 10, you're going to end up with negative 7. 3 minus 10 is negative 7. Use your calculators, it'll show you. So you're going to have negative 7x plus 5. So the answer is negative 7x plus 5. That's how we arrived at that answer, because we combined the like terms, okay? So let's look at number 2. Let's look at number 2. What are the like terms in number 2? Negative 4x and negative 6x. So we're going to combine those two here. And the positive 7, that's in the constant family. That's in the number family. So we're going to put that right here. So let's go ahead and put in our positive 7 now. And negative 4 and negative 6. If you type that into your calculator, you're going to have negative 10. And since those numbers are part of the variable family, we're going to end up with negative 10x plus 7. So let me just type that in then, all right? Negative 10x plus 7. So that's how we combine the like terms, okay? So now we can move on. We can move on. So I'm going to clear these. Let's move on. These are similar, so you can do the same thing. You can do the same thing. Let's move on to the anticipatory set. All right. We're going to figure out how we can solve for the variable. We're solving for the variable. So what's the variable here? The variable is x. So we want to solve for x. So we want to find out what x is. And in this case, at number 2, the variable is x again. The variable is x. So we want to find out what x is. So let's solve for this variable. I want to do this very quickly. Hopefully you can follow along. All right. So I'm going to do what we call distribute. I'm going to do what we call distribute. distribute. All right, so we're going to distribute. Now, when we distribute, what we're going to end up doing is we're going to take this number outside of the, you see the number outside of the parentheses, the 3. We're going to take that number and we're going to multiply it onto the variable and then onto the constant. Now, notice that there 3 times x, and then we're going to do 3 times -1. Okay, here's the equal sign. Right now, it just has one constant on this side. So since it's just one constant, we're fine. We don't have to do anything. So 3 times x will be 3x, and 3 times -1 would be -3 equal 9. That's the first step. That's the first step. Okay. And now we need to find out, we need to solve for the variable. So what's the variable? The variable is x. So we want to solve for x. We need to find out what x stands for. So now we have 3x minus 3 equals 9. This is where I'm going to go very fast. Okay. So we want to have just the x on this side of the equal sign. All right. Remember, sometimes we used to say that the equal sign is like a river. It's like a river, like a river. So we want to have the variable by itself on this side of the river and the number, the constant, by itself on the other side of the river. So to do that, we need to add 3 to both sides. All right. So plus 3. All right. So -3 plus 3 is 0. In your calculator, -3 plus 3, or -3 plus 3, is going to give you 0. So this what happens. We have 3x plus 0. And here's the important thing to keep in mind. We don't have to put the plus 0 if it's not going to be there. So we'll just have 3x, okay? We'll just have 3x, and 9 plus 3 is 12. Keep in mind there's an equal sign here. This little river is an equal sign. So 3x equals 12. Well, there's this thing called the inverse operations. We've talked about it before. Hopefully you remember. The inverse is the opposite. The inverse is the opposite. The opposite, all right? So the opposite of addition is subtraction. The opposite of multiplication is division. So we're going to have to do the inverse operation to get x by itself. Look, I want x by itself because I kind of like x. I think she's cute. So I want to make sure I get x away from 3 because I can't stand 3. He's a big football player. I don't like him. All right. So I want to get x by herself. All right. So let's do that. I'm going to divide. I'm going to find a way to divide or separate x and 3. The way I'm going to separate them is by dividing. Now, if I do it on one side, I have to do it on the other side. Okay, so 3 divided by 3 equals 1. And I have my x, so bring down my x. And the good thing is, if it's just a 1, I can erase that, okay? I can erase it. All right, so now I have 3x, I just have x. I just have x on this side, x. Okay, what is it? I messed up. Here we go. So x, and what's 12 divided by 3? In your calculators, it's 4. So the solution, the answer is x equals 4. So we can go ahead and put our answer right here. X equals 4. Good. We had to go through that whole process. We had to go through that entire process. Okay. But that's okay. That's what we do sometimes. So now we've solved